All right, so today let's just go ahead and get in our bag and we're going to actually discuss and demonstrate inbound NAT on a Palo Alto firewall. We, of course, in previous videos, we've got this Palo Alto VM that you see here configured along with a Linux, AWS Linux test server in a separate subnet. So we're just going to basically demonstrate SSH and HTTPS using one elastic IP and, of course, discuss how we can achieve that. So let's take a look here and just really write what we're working with. We've got a firewall here, and then we've got ETH11, which is our outside 10.0.1.100. Then we've got ETH12 10.0.2.100, and our management is going to be 10.0.0.100. We'll call this inside. And then we, of course, got outside. And so we also have, we should have did different colors for that. But our server, I think without looking, it's going to be 10.0.3.100 if we're following that same. Got that. This is just to give folks a quick visual. Yep. And then, of course, tied to that elastic, let's go ahead and write down that last tidbit that we'll need here. And 54.87.102.195. So those are all of our components, other than one quick thing that we need on our Linux, which is going to be the key pair name, and that is SSH key 1, SSH key 1.pem. So cool, we've got everything that we need to do this, and we're gonna get started. So here in our Palo Alto VM, we have this pre-existing outbound NAT security rule, and of course the corresponding NAT. Now the thing to know, especially when it comes to inbound NAT, is that a Palo Alto VM actually does the pre-NAT first. And then we're going to actually see that and explain it. It'll be a little bit easier as we build the rule. It's the source and destination zone that, especially if you're coming from a Cisco world, that to some, and it took me a while, it makes no sense, but it's easier to see that as opposed to doing it. So let's just go ahead and hop right in. Let's start with our security rule. NAT is going to be easier to explain, but we'll configure one before we see here. Actually, let's start with what we're working with. Let's get back over here. We'll go red. And so what we're going to do is, to this server in the inbound direction, we're going to use for SSH, we're going to actually use port 5001. And then for HTTPS, which we may have to configure that, we'll use 8001. And of course, both of those will use this same public IP address. So how can we actually do that? So that's what we need to do. Let's first configure that security, our SSH rule. So we'll come in here, we'll click add. We'll name this SSH inbound to Linux EC2, or actually to Linux 3.100. Yeah. And description will be permit inbound SSH on port 5001 to Linux host. We could do the whole IP 10.0.3.100. Description's good for if you work on a team and someone's doing cleanup, etc. Some people will put like when this rule was made in description, but of course over here you can already see those things. And then the thing about the security rule is it is evaluated post NAT. That's why I probably should have did the NAT rule first. So really once NAT is performed, where is this traffic actually coming from? And the source is going to be public. And then the source address, we're going to permit anyone on the internet to hit that. And on the destination, we need to ultimately get to that server, NAT having already been performed, or let's imagine that it is. That's going to exist actually in the private zone. And then our destination address, we'll keep any for now. Application, this will be, we'll add SSH here. We'll type it real quick. We'll do that. We'll hit OK. And for our service, if we hit add, let's go ahead and add a new service. And we'll just name this SSH 5001. This is TCP port 5001. We'll hit OK. And then the defaults permit there. And so that looks good. Let's actually, it really doesn't matter for the sake of this. But let's move this to the top. Now let's do the NAT, which again, traffic coming from the internet here before it's NATed, it's actually going to, again, be on the public zone. But the destination before it's NATed is that outside interface. So you'll see here that shortly. This is SSH inbound NAT to, what was that, Linux 3.100. And this is a NAT rule to permit inbound SSH to Linux host 10.0.3.100 and translate it to TCP 22. This will be a tag of SSH as well. And that's where we're saying here, this original zone is still public, as you could imagine. But this is where the destination zone, before it's NATed, it still needs to hit that outside interface, which is ETH 11. The service should already exist here in our drop-down menu, so we'll click that. And then for our NAT, source would be any. Destination is going to be that private, which is 10.0.1.100. So we'll hit OK. And then our destination translation, we need to now, when it comes in on port 5001, we need to translate that towards the server, which is 10.0.3.100. And we need to, of course, translate it to the true service or protocol that's used. We don't really need a, can we do none here? No. Oh, I clicked this, sorry. Trying to look around this camera. Dynamic with, let's do static IP. There we go. 10.0.3.100. We'll build some address objects here as well to make this a little bit easier on the eyes. And when this traffic hits the server, let's go ahead and make it look like it's always coming from the firewall's inside interface. So we'll do interface address, and then we'll select ETH12, which is the inside. All right, so we got everything set there. We'll do some cleanup and niceties here in a wee bit. All right, so let's commit that. And because we're not going through a panorama, this should be way quicker than we see on a panorama. We'll pull up this here. Again, we got SSH key1.pim. And so we're basically in that directory that contains that. We're getting ready to test that coming in. Once this rule hits, all right, so we see a hit count of 0 there, so that rule is set and ready to go. So let's just, we'll SSH dash and we'll use SSH key1.pim. We'll be coming in with, this is Linux EC2 user at, and we need that public 54.87.102.195. And we need the port to be across the internet, -P5001. All right, so let's hit that, and we're in. So again, if we do, I don't know, ls, there's nothing here. If we do oh, sorry, there's nothing here. Nothing here. Oh, there we go. So we're just hidden files there. And then, of course, our outbound should be working with the pre-existing rule there. But let's go ahead and this one will bring up here. Let's copy all these commands to enable HTTP. Let's make sure this works to bring up that server. I did one command. Yeah, I think. Update. All right, so we gotta do the other two. All right. Sudo yum install HTTPD. So we're good with one, which is the SSH, but to enable HTTP, which is probably going to be a test page on this server, we need to basically enable HTTPD. Okay, start. It is started. Sudo systemctl enable HTTPD. Good. And let's make sure it's up. Status HTTPD. All right, so it's running. So for this, we should be able to hit that. We're going to make this port 8001, but we don't have that configured yet. Now that we kind of know what to do, let's just start here, and it'll be very similar. So let's just clone it and change what we need to change. So we'll clone this and we'll see if we adjust these columns. This is going to be changed to HTTPS to inbound NAT. So that's a different name. This will be a NAT rule to permit inbound. Actually, HTTP, we don't have our certificates. Translate to TCP. So this will be 80. All right, so we'll do original packet. We need a new service. So we'll hit new service. This will be HTTP 8001, TCP 8001, tags. We'll just add a tag and we'll leave the description off there. Destination the same, translated packet will be the same, but the port will be 80 towards the same server. And of course, we still want that traffic to look like it's coming from the firewall's inside interface. We'll go to security. And similarly, let's go ahead and clone this rule. We'll just make it after, and we'll rename this as well. This will be HTTP. This is the lazy man or woman's way. Permit inbound HTTP as opposed to just creating it new from scratch. That's cool. This will be, we probably missed taking away the other tag. Source, same here, destination. This will change to, I think web browsing is 1. Excuse me, I think it's hyphen. And because normally we do SSL, but again, we don't have a certificate. We know the default action is allow, and so we should be good here as well. Let's, what am I doing? widening the columns. So we'll commit that as well. And we honestly should be in service. But after this, again, like we noted, in production, to make this a wee bit better, instead of putting IP addresses more so here, we could, let me close this. Let's just copy this IP 10.0.100, and we can call it what we want, but we can come to object, addresses. Let's add one, and we'll name this, this is a north-south firewall, but we'll put Palo Firewall inside interface 1A in case we ever do a 1B, a firewall in the other zone. And we will leave a tag off of this for now. And so now if we come back to our NAT policy and we update this in this way, like if you ever have this and you need to like make changes to 100 different rules, you just change the parameter, the IP, for example, in that object, and it'll automatically update it everywhere. So something we'll do there. And if you ever want to see the value, you just click this down arrow, hover over value, and it'll tell you what that translation is. There's FQDNs that you can do as well. We'll do one more real quick before we hit that IP. This will be our Linux web server. Call it 1A as well. We could have put IPs, but we would probably put that in the description. 10.03.100. We'll come back to policies and we'll update this as well. And one thing that we're not going to do in this video, but now that we're starting to make security rules, etc. in AWS, we need to clean up our security groups and tighten those up. And so now that we know, like from the web server, what we would do is on the inbound security group, the inbound rules, we would just permit port 22 and port 80 from the firewall's inside interface, and nothing else would be permitted. And we would, basically be tightening it up. All right, so now let's go ahead and let's open a new tab. And we'll do 54.87.102.195 colon 8001. And there we go. It works. So that's what is configured to be displayed there. And if we come back here and refresh, yeah, we got one rule hit there on the NAT. And if we come back to our monitor, we'll see that if we're going to do destination, it's going to be everything that's going to 10.03.100 is what we're looking for. Oh, that's the NAT destination, sorry. Apologies. Yeah, right here. So this is a packet for 8001. Not sure why we didn't see the 5001, because the reason, in case anyone's curious, is because on our NAT, or actually our NAT and security rule, we have, I think, logging, or actually it's going to be the security rule. For SSH, we have logging at session end check. That's the default here, so not at start. So until we come back here and Control C, if we exit out of there, we should now see that log entry appear here shortly. Or one would surmise that it's coming here pretty shortly. Let's see, 5001. Yeah, Not sure we're not seeing that yet, but it should pop up here shortly. But again, that's really, like I said, in a nutshell, demonstrating the inbound NAT, especially when you have one elastic IP address in a cloud environment. I mean, we can put multiple elastic IP addresses there. If ever we needed to, we would come here underneath Palo Alto Firewall. And like I said, we're going deep in our bag here today. We will go to networking, and basically we find that E and I, our elastic network interface, and that index value of 1 is our public. We'll right click, we'll open the tab here, and then we would highlight this, and basically under our actions, we're gonna manage, well, actually, truth be told, we could do it from the firewall itself. Actions, networking, manage IP addresses, and we'll see the two public. ETH1 is our management. That's how we're into our console there. ETH1 is our public, and we would just click assign a new IP. And this is if we wanted to do like a 1-for-1 NAT. Say we didn't want to share for each of these new data flows. If we had another server using that same public, we wanted it to have its own unique public IP address. We would just assign a new private address .101, and then of course we would need to allocate a new public IP address and attach it here. And then now we got two public IPs to set our NAT rules to. So again, this is all about the design. Once we get, to that point of growing the network, growing the number of resources, servers, databases, etc., whatever we're hosting or really serving up to clients, that's where some of these differences, and not to say thoughts, but what you need for your own organization come into play. But like we said, the key takeaway, like I said, here is that for our NAT rules, really for those zones, it's going to be pre-NAT. So it's almost always going to be in the inbound direction that a client or a packet's going to be coming into that outside interface. The source is going to hit that. And because it's not NATed yet, it of course is going to be destined to that outside interface. And then once that NAT or post-NAT occurs, for the security rule, once it gets to that area of the flow, the source again is going to be, of course, clients coming into that public or outside zone. But the destination now, where does the true destination lie? And of course, our Linux server is on that trusted or that private zone there. So that's really, once you lock that in, then everything else kind of falls right into place. But I want to thank each and every one of you again out there for always rocking here with me today. This one's a little bit long, so again, thank you for everyone that's hung in here. We've had some folks that have asked or requested certain videos, this being one amongst them. So hoping that you found some value, and always feel free to lock in, comment down below, let us know what else you want to see. But until next time, stay safe, take care of yourselves. Peace.